Right, so these are the solar panels, which are a bit old and decrepit now because they've been about 5 years up here. So now I'm having to reinstall them. I'm not going to change the construction much because all the box does is really hold it together. So you can see this is just a pressurised timber, and then underneath this is a sheet of plywood, and in between is some polystyrene to give it a bit of insulation. But the box is holding together, so there's no need to replace it at the moment because, like I say, all it's doing is holding the pipework. The main part of it is this. This is the aluminium sheet. I think I went for about 2mm, maybe 3mm aluminium. Doesn't have to be too thick. It's purely just there to put the temperature onto the copper piping. And you can see the black part, which is the copper piping. That's the 8mm copper piping. And the cleats were just made out of pieces of alley. I'll show you some in a minute because I'm slowly putting these back together again. Originally this was one panel, which gave me quite a good temperature, and I've decided to make another one up, and I've just connected them up in series now. So my pipes from the downstairs from the pump system comes in through one of these, and then feeds back up to my cylinder. So these are the connections that I've still got to make up, which I'm going to do today. The first bit that feeds through goes straight through to the next panel, and these are one of the cleats that I was talking about. It's just a bit of the old alley that was cut off that I hammered around a pencil, and then they will just screw over and hold the copper pipe into the alley sheet. And then that goes into that panel all the way up the top, back down, and into this panel. And that's about it for the panels. Quite an easy construction really, anyone could knock these up. And to go on top of these is I have 2 sheets of glass. I did plastic at first. Plastic works quite well. I did a test on plastic and glass, and they both come out the same in temperature, but glass is easier to clean and keep clean. So I was lucky. I had an old double glazed door, patio door, double glazed unit that I took off and split, and that's these 2 sheets of glass here. So these are toughened glass, and they're big enough just to fit the panels. The panels are made to fit these actually. So I'm going to get on with constructing that bit, and then I'll show you the inside and how it all connects up.
So to get the temperatures from my solar panel and to get the temperatures also from my water cylinder upstairs, I use a temperature probe, which is a digital one, and which I've got a test Pi, this is my test Pi at the moment that I've set up in my office, which connects up relays and stuff. And I've always had a probe connected for doing some tests when I'm doing some programming. And these probes are digital probes. These are D18S20, which I'll update my website with it and the program to run it. And these are digital probes, much better than the analog ones that I used to use at the beginning. And we can daisy chain these together so that they have a positive on the left hand side, a negative on the right, as you look at them here. I don't know if you'll be able to see it. And the white cable is my data cable that's going into the Raspberry Pi. And I'll show you the wiring for that in a minute. And all that happens is it pulls, every single probe has an address, and you call that address and it sends the temperature down the data cable to the Raspberry Pi, and you can have multiple ones of these chained along, all on the same data line. So they're quite handy, and I use that for my central heating system, which I'll be going over at some point. So for now, I'm just going to show you this probe here set up, and then I'll show you the one that I'm going to be setting up for the actual solar panel. So the first thing I'm going to do is, this is already connected up, the Pi is already running, so I'm going to bring up the program for it and show you how it's programmed. If you just give me a minute. Right, so first thing I'll do is to show you a website for the wiring. So this is a good website here. You can Google this, just Google the DS18V20 temperature probes with Raspberry Pis, and it come up loads of ways of connecting them up, but they connect up to the GPIO pin 4, which is what I've done. I've got a 3.5 volts going up to the positive and the ground, and a 4.7k pull-up resistor between the positive and the data line, which is connected up at the Raspberry Pi end. And then this length, if you're looking at lengths, I'm running mine probably about, I don't know, got to be over 10 meters. I've got quite a few of them all around in the house, so they can go quite a way. And there is some software to be done on the program, on the Pi, just installing basically the wire library for the GPIO pins, and again I'll put some links for this or update my website with how you set this up, but it's very simple to set up. And so we get rid of this and I'll show you the actual program for it. Right, so the first thing I need to do is get the Python script up and running. I'm going to show you this Python script, which is a basic one that I've been running for a test program. The first thing I've done is put the address into a variable called temp file, and it's the address that the probe file is kept on the Raspberry Pi, and I'll show you where that is on the Raspberry Pi if you're using BNC View or whatever way you connect to your Pi. So you bring up the directory, and from the main directory at the top, if you go down to the SYS, which I think stands for system folder, and expand that one, and then go down to devices and expand that, and then you're looking for the W1 underscore bus underscore master 1, expand that, and you get the address. After you've rebooted your Pi, you should have an address in there beginning with 28, and that'd be your probe address. So all you need to do is I'll rename and copy that address there, and you can get this through your terminal as well, so you don't have to do it through VNC, but any way you get it, you need to get that address. And then in your main program, that is going in here, so I'll paste that into there. And so the main address is system/bus/w1/devices/ the 28 address that you had /w1_slave. So the main program at the bottom, I'm calling I've made a function for reading the file, and the reason for that is that I do run multiple probes, and normally I run a while loop, which I'll do in a minute, which reads off these probes rather than keep writing them out for every individual probe. So this part of the code down here is just calling this function, and it's going to store the result into temp and then print it out at the bottom. So we're going to need to, when we call the function, we're going to need to send it the probe address, which is the temp file which we set up here. So that's going to call the function and send it that file and store it in the letter capital T, which could be anything you want to call it, as long as it's the same throughout the function. So the first thing the function is going to do now is to open up the file. So it's opening up T, which is the file at the top, and then it's going to read that file. And I've printed out, just to show you, I've printed out every now and again each part of this function, which I don't do on the main code, obviously, because it'll take up a lot of resources. But I've just did it here to show you, and it's handy to see it myself for when I'm testing stuff, because this is only a test file. So we're reading the file, the whole contents of the file, and I'm storing it into temp, and then I'm going to print out temp. And over here in the comments part is what actually gets printed out. As you can see, there's 2 lines of data that gets printed out, and it's only this part at the back here that is the temperature bit that I want. So we got all of that stored in there into temp, and so then I close the file down, so don't leave it open. And the first thing I'm going to do is split down this file so that we go into the second row on this bit. So we're going down to here, and then we're going to split it further to this space, 9 spaces along. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and it'll split it off there, and it'll store that T equals 23687, or whatever the temperature is at the time, will be stored into data. And I'll print that data, and it'll show you that print out from there. And I'll show you this working in a minute. So now we need to take just the 23687 off and get rid of this T is equal. And I'm doing that through this bit here where it says the floats data to 2 dots, and we're storing that into get temp. And then I'm putting that get temp, and we end up with just the figures for the temperature. So the temperature on this, when I did this bit for the comments, was actually 23.68 degrees Celsius. So I need to move that decimal point 3 points to the left. So I'll do that by dividing get temp by 1000 and storing it back into get temp, so overriding the first get temp. So it's just overriding whatever's written in get temp now. So if I print out get temp now, I'll end up with the 23.687, which is if you want the decimal points in your probe for any calculations or any displays on a website or anything, you can use that and round it up whatever way you want. I round mine up to 0 because I only need the temperature of the panel for this program, and I'll do that through round get temp, which rounds it up, and store it into temp rounded. And then I'll return back to the bottom part of the code, round get temp, temp rounded, which will return the temperature, and it'll be rounded up for this one to 24 degrees. That gets stored into temp because of return, and it prints out temp as 24. So it's quite a simple program, and this is the building blocks of all of the temperature probes that I do around the house. So I upload this to my Raspberry Pi, and hopefully you already know how to do that, which I use FileZilla for. So this is my test temp, and it goes, if I double click that, it will upload it now to over here. So it's already uploaded, and then in my VNC I'll bring up a terminal. Now you can do this with a terminal for VNC, or you can do it through PuTTY, whatever way you want to do it. And I'm putting in sudo python testtemp.py, which is the program that I'm running, and if I click enter, you can see there I've got exactly what I showed you earlier. We've got the 2 lines of data at the top. This time it's t is equal to 24062. So then we split it down to get t is equal to 24062. We take away the t equals to end up with 24062.0. Divide it by 1000 gives me the 24.062, and then I round it up to end up with 24. And that's the basics of getting a temperature of one of the DS probes. And so what you can do then is put a while loop in here. While 1. I'll save that, upload it to the Pi, and then I'll rerun that code. And as you can see now, it's printing out the temperature every single time it goes through the while loop. So that's how I get the probe temperatures. I'm continuously reading the probes, and then I can build up my Python script. Right, so the next thing I need to do, because this is only a test one at the moment, right, so this is going to be my actual probe, which I've just soldered on, and as you can see from what we were saying earlier, there's the positive on the red on the right hand side, as you look at it, negative's the black, and the data line is going to be the white one. This is connected onto a long curler cable at the moment. I'm now going to connect this up to my Pi, which I'll show you. First thing I'm going to do is shut the Pi down. Right, to connect up the probe, I've got a terminal bar over here which is connected up to the same pins this probe's connected up to, so I can show you how it daisy chains across. And this is quite a good little setup kit if you decide to build one. I'll just speed it over a bit. And it allows you to connect things up to test, and this is what I use it for, testing. Best thing is just turn the your Pi off and unplug it before you do this, in case you short sight out. Right, so that's now connected, and I'll plug my Pi back in so allow it to start up. See that work in a minute. Right, so I just had to start the Pi up and reconnect it for the VNC and the FileZilla and everything, so I can get the probe. So now we've connected up another probe, and we've restarted the Pi. We go back into the file directory that I was in earlier, which was SYS, devices, W1, and you can see that I've now got 2 probes, one that was on the board and the one that I've just connected up. So looking at my code earlier, the one that I originally had ended in 81EE. So the 81EE at the bottom is my original one that's on the board, and this is now my new probe that I've just connected. So I'm going to get a copy of that code, so copying that address, and then in my script I'm going to paste it into here, and that's it. Save that, upload it, bring up the terminal, and all going well, I should be getting, it's 23 degrees it's showing on the screen. Now I'm just going to hold the probe with my fingers, and you should see that probe going up. It's gone up to 24 now. and it's 25, so it's going up. You can see that that's the actual probe that I've connected up, running now. And I'll show you reasons why. Again, I said I do the function side of it, because if I put the old code back in, right, so now I've got the top one is the one off the board, the bottom one is the new probe that I connected up, but this one's going to be putting into new file. So down here I'm calling read temp file, and I'm going to have to do the same thing again. Copy that. I'm going to do read temp, but this time I'm going to do new file, and I'm going to store that into new temp here as well, and then I'll be able to print out that again, new temp. So we'll be calling the first one, which is the one on the board, then we'll be calling this one, which is the new one I've just connected up, which is going to be my solar panel later on, and we're going to print out the board one, and then we're going to print out the new one. So you can see why I use a function and this system, because I could be doing this quite a lot. Right, I don't know if you can see that now, but I'm probably better off not doing it in a while loop. But there's one, you should be able to just about see one going through at 27. I can put a sleep and delay on this, but I'm not going to, it can take longer. But you should be able to see the bottom one on that temperature. If you pause your video, is going up to 27 degrees. That's the one on the actual PCB, originals. And then if I touch the other one, that should start bringing the other temperature probe up. There's a lot of data on there which is causing the problems, and just to get rid of that, I could just hashtag out these prints. They're really annoying. Right, so there we go, we've got the two temperatures there, both at 25 degrees. And I'm touching the one on the PCB, which is going up 27, and the other one's at 24. That's a much better way. And now I'm going to put my fingers on the one that's for the solar panel, which is just going up now. 26, 27 is the top temperature. 27, you see the bottom one's going down because the temperature's dropping. So there you go. Hopefully you understand what I'm doing there. I've got the two probes connected up on a daisy chain. They're both being called through a function and being printed out on the screen. So the next thing now is to physically wrap up that probe. What I've got to do now is put some insulation around this probe, so that the connections, which are still being shown, so them connections are insulated. I use some insulation tape and then some heat shrink, which has got some glue in it to insulate, and then this will be connecting up to my panel, and I'll show you that later. And then I'll run the cable down to my actual house server, where I'll be showing you how the actual program works for that.